Okay, today we're going to learn how to calculate the standard deviation from a set of numbers. And basically this is kind of difficult to read, but let's go ahead and redraw some of this. So go ahead and draw this one on the bottom. And I'll kind of explain what standard deviation is, and then we'll calculate it from a set of numbers here. So let's say in the middle, and go ahead and draw a line down the middle. Okay, so let's say this is average, whatever the average may be. And then draw another line in between there. One more there, and maybe one more there. And then on the other side, there should be some lines here. Okay. And so what we're looking at is, let's say this is the average right in the middle, and this is a normal distribution. Your mean, median, mode, and everything's pretty normal. If you're within one standard deviation, meaning we're going to find this value right there, excuse me, one standard deviation this way or one standard deviation this way, you're pretty, I guess, normal. In fact, if this is it is 34% in a normal distribution, 34% there, 68% of all the data is within one standard deviation away from the norm. Okay, and then if you go a little further away, it's less, I guess, normal. But anyway, what we're figuring out today is this number right there and this number right there. This is the standard deviation. Okay, and so we're going to do that through a bunch of calculations. Okay, and then looking down at this, there's all these little Greek symbols here. This tells you how to find the standard deviation. Looks pretty confusing, but it's really not. There's all these just different symbols. But this symbol, it's a Greek symbol, sigma, it's a lowercase sigma. That's standard deviation. Okay, do we have to memorize what these symbols mean? Probably, and yes. Okay. This symbol, I think you've seen it before. This is the summation, but this is a sigma, capital letter sigma, summation. That means you're just adding up a bunch of things. Okay? And in fact, if you add up a bunch of things and divide it by the number of things in the set, that's giving you an average. Right? Okay, and I know this doesn't mean a whole lot to you, but another symbol, and I'll explain this, and we're going to actually go through all this with some numbers. This X with a line above it, that means the average. This is that. So X with that bar is the mean, the average of the data set. Okay, and just X, that's just one of the numbers in the set. And obviously that is a square root. Okay, so doesn't mean a whole lot to you, but to find the standard deviation, the distance from there to there, or there to there, or there to there, each of those is one standard deviation. This is what you do. And again, this is not going to mean a whole lot until we actually sit there and do these with some numbers. But first you find the average. We know how to find the average of a set of numbers. You just add them all up and divide it by the number of numbers you added. Okay, this step 2, you find the difference between each data value and the average that you find. Okay, so you just subtract them. Okay, then you square that number. And we can all do that, and we're going to do that on a calculator. And then from there, you're going to average all these values that you get. Okay, so that means you're going to add them up and divide it by the number of numbers you've got. Okay, we average that. Okay, and then after that, you're going to take the square root of that number, and that's the standard deviation number that you get. Okay, so didn't mean a whole lot, but you have an idea that you're going to do a lot of number crunching. So let's go ahead and do one. So turn it over. And here's a set of numbers here. Get your calculator ready. It says find the standard deviation of the data for this set of numbers right here. You have two, there's kind of a real small set of numbers. 1, 2, 3, 4, 5, 6 numbers. So you got 2, 4, 6, 7, and 9. So they organize it real nicely in a little table here. So let's go ahead and use it. So let's write the numbers that we have down. This is X. These are numbers in the set. So 2, 2, 4, 6, 7, and 9. So those are all the numbers in the set. Okay, let's go ahead and find the average. So let's find the average. And so on your calculator, you're going to add those up and then divide it by, I think, 6 numbers. So go ahead and find the average. 5. So it adds up to 30. And then we divide it by 6 numbers. So 5. So that's the average. Okay. So I'm going to put that in all these spots right here. So 5, 5, 5, 5, 5, and 5. Okay, and then they want you to subtract, excuse me, this x minus this average. And I know some will be negative, some will be positive, but eventually we're going to square it, and it's always going to be positive. But 2 minus 5 is negative 3. 2 minus 5 is negative 3. 4 minus 5, negative 1. 6 minus 5, positive 1. 7 minus 5 is 2. 9 minus 5 is 2. So we're just subtracting this minus that, which is 4. Sorry. Okay. Okay, then they want you to square each one of these. So negative 3 times negative 3, these are always going to be positive. So 9, 9, negative 1 squared is 1, 1, 4, and 16. Okay, so we found the difference, and then we square it. And by the way, so when we subtract, even if I went, instead of 2 minus 5, I just found the difference, like 5 minus 2, that's 3, but square it's 9. You're going to get the same number over there, whether you go 2 minus 5 or 5 minus 2, because you're going to square it anyway. Okay, so now they want you to average all of these. Okay, and this is what the symbol means. You subtract all these, we squared it, we got that, and this summation symbol, sigma, means you add those up and then divide it by the number of numbers, which is 6 of them, right? And you'll divide it by 6. So add these up. Tell me what you get. Okay, 40. Okay, 40. And divided by 6, so we're adding 16, 4, 1, 1, 9, and 9. Okay, so divide that. 6.6. Is it repeating? Okay, so 6.6 repeating. Okay, and this is actually called variance before you square root it. This is called, and go ahead and write this in the column over here, variance. And actually it's a symbol. It's this little sigma symbol, but squared. So go ahead and write that down. So before you square root it, that gives you the variance. Okay, now to get the actual standard deviation, you just take the square root of that. So square root of 6.6 repeating. So make sure on your calculator you go 6.6666, just write them all out, a bunch of 6's, take the square root of that, and that's the standard deviation. So what did you get? 2.5818. So let's call it maybe 2, 3 decimal places. Okay, and then this is our standard, so write this down, standard deviation. Okay, so 2.58, about 2.6, so that's standard deviation. Okay, what did we just find? Can we just turn this over this chart? So the standard deviation, let's say it's 2.6. So I'm just making this up. Let's say the average, I know it wasn't 10, but the average was whatever, 5. Actually, let me just put that. If the average was 5, then one standard deviation would be 2.6. So that would be 7.6. Add another 2.6. That's what, 10.2, and so forth. So that's what we're finding. So then if we score at 8, we know within 2 standard deviations of being normal, or whatever, comparing towards the average. Okay? So today we're just doing an exercise and finding these numbers, number crunching. Okay? All right. So let's go ahead and do number 2. So we got these nice short set of numbers there. There's only 4 numbers. So let's find the standard deviation for these numbers. Let's write these numbers down. 13, 8, 3, and 12. Okay, so add those up. Divided by 4. This will give us our average, because we need that. So it adds up to 36. So what's the average? 9. Okay. Let's put 9 there, 9 there, 9 there, 9 there. Okay, then we find the difference. So 13 minus 9 is 4. Squared is 16. 8 minus 9 is negative 1, but squared is 1. 3 minus 9 is negative 6. Squared is 36. 12 minus 9 is 3. Squared is 9. And then what do we do with those numbers? Add them all up and find the average of those. So add those up. 62. So 62, we divide that by 4. That gives us 15.5. So what is this called? The variance. But now take the square root of the variance. So square root of 15.5, that's close to 4. What is that?
How many places do you want to go past?
We'll go 3 decimal places. 3.937. Okay, so that's our standard deviation, about 4. Okay, so if 9 is the average, every 4 away from that, that's with 1 standard deviation. Okay? All right, so pretty easy to find standard deviation? Okay, so let's look at this other paper page you have there. Okay, now we're going to look at what happens to the standard deviation and the average if we add some numbers, add numbers to all the numbers in there, or if we multiply, see what happens to the standard deviation if it throws it off. Okay. All right, so these 4 numbers, find the mean and standard deviation of these 4 numbers. So let's go ahead and find the average first. So average those numbers. Okay, so it adds up to 30 divided by 4, which is 7.28. 7.5? 7.5? Okay. So that's the average. Okay. And then I'm not going to put this in a table. I usually don't. I mean, this is a very nice way to organize it. And you can if you want. Put it in a table. But I'm just going to just start averaging the differences squared. And I'm just going to start writing it down. Because I know I have to take the difference between this and these numbers and then square it. So I guess I'll write it down this time. But then by the time we do these down here, then you're going to just want to just write without doing it. But I'm going to go 7.5 minus 3, right, squared, plus 7.5 minus 5 squared, plus, so I'm finding the difference, squaring them, and then I'm going to average all these. So I'm adding them up. Plus 7.5 minus 10 squared, plus 7.5 minus 12 squared. So I found the average. I'm finding the difference between them, and then I'm squaring them. And I want to average those values. This is exactly what we did in the table. So I'm going to divide that by what? There you go, 4. Okay, so I guess I'll write this out. So, and by the way, we could have gone 3 minus 7.5 and 5 minus, right? But it doesn't matter because when you square, it's going to be the same number. Okay, so I guess I'll write this out. 7.5 minus 3 is 4.5. I'm going to square that. Plus what? 2.5. 2.5 squared plus negative 2.5 squared. I could even say that's going to be 2.5 squared. Same thing. Plus, is that 4.5 or negative 4.5? Okay, negative 4.5. Sorry, I'm running out of space. Squared divided by 4. Okay, then I will, well, you'll help me out because you have a calculator and I don't. But what is 4.5 squared? 20.25 plus, I know 2.5 squared is 6.25 plus another 6.25 plus 20.25, negative 4.5 squared, divided by 4. Pretty easy, just got to crunch a lot of numbers. Okay, so we're going to find the standard deviation, so add those up. 53. Okay. We'll trust Nico there. 53. Do we trust Nico? No, there's a quarter, 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 and a quarter. 26, 52. No, it's 53. Nice job, nice job. Divided by 4. And so what is 53 divided by 4? No, 13. 13.25. Okay, then that's variance. So how do we find standard deviation? Square root it. So probably 3 point something. 3.64. There we go. Okay, so that's our standard deviation. Okay, so now let's see what happens if we, so it says now increase each number by 2 and recalculate the average and standard deviation. How does this affect the mean and the standard deviation? Okay, so take all 4 of these numbers and we're going to add 2 to them. So instead of 3 we have 5, then we have what? 7, 12, and 14. Okay, so they want us to recalculate and see what happens. So what's our average? Let's find that first. $38 divided by 4 is 9.5. Okay, that makes sense because if the average up here was 7.5 and we added 2 to each number, it's 9.5. 2 more, right? Okay, now let's find the standard deviation. So what do we do with this 9.5? You subtract it from each one of these, right? So what's 9.5 minus 5? 4.5, okay. 4.5, I know we're going to square it. Plus, what's 9.5 minus 7? 2, do these look familiar? So that's 2.5 squared plus 2.5 squared. I'm going to, well, I guess I'll put negative 2.5 squared plus negative 4.5 squared divided by 4. Do we have to actually do any calculations on the calculator? No. No, why not? Because it's the same thing. Okay, so this ends up being 13.25. We know these are the same exact numbers we had. Then we take square root of that. So square root of that. And you're going to get 3.64. So 13.25. So 3.64. So if we add the same number to all the numbers in the set, does it change the standard deviation? No. Why not? Well, mathematically this is why not. But if the spread of numbers, they're the same. They're the same. So it's not going to change the standard deviation, right? What is a spread of numbers? Spread of numbers are if you had, let's say this was simple. If you had 7, a 6, an 8, a 7, a 7, a 8, they're all about 7, the spread is less. Your standard deviation, when you figure it out, it's going to be a smaller number. The bigger the spread of numbers, this is kind of a big spread from 3 to 12 and 10 and 5. So your standard deviation number is kind of big. Okay. All right. So answering this question, thus, if you have a set of numbers and each number is increased by the same amount, the mean, how does it affect the average? How is the average affected? Increases by that same amount. Okay, so we'll put increases by that amount. So if you add 2 each time, the average increases by 2. If you add 7, the average is increased by 7. Okay, and what happens to the standard deviation? Stays the same. Okay, so stays the same. Okay? Okay, part C, now multiply each number by 2 and recalculate. Okay, so let's go back to this. Let's multiply by 2. So what are our numbers? 6, 10, 20, 24, right? Okay, so let's go ahead and find the average. So add those up, you get 60 divided by 4, which is 15. Okay, that's, yeah, so that's a nice whole number. That's good. Let's go ahead and calculate the standard deviation. Okay, so let's go ahead and do some of this in our heads. So I know I have to subtract it. What's 15 minus 6? 9 squared plus 15 minus 10? 5 squared plus 15 minus 20? Negative 5. In fact, I can even put 5 squared because it's going to be the same, right? Plus 9. 24 minus 15, 9 squared. We'll divide that by 4. So 81 plus 25 plus 25 plus 81 divided by 4. So add those up, divided by 4. This will give us the variance. 53. What did that add up to before you? 200 and something then? 212 then? Divided by 4. So 53. So that's the variance. And so what's our standard deviation? Square root of 53, which is 7 point something? 7.28. Okay, there we go. Well, wait a second. How does that compare to the standard deviation of it's multiplied by? Is that exactly multiplied by 2? Okay, multiplied by 2 because we multiplied all the numbers by 2. What happens if we had multiplied by 3?
Most likely that would triple.
It would most likely triple that number. If we multiplied everything by 5, it would be multiplied by 5. And that is true. Okay, thus, if you have a set of numbers and each number is multiplied by the same amount, the average, what happened to our average? So if we multiply by 2, the average of 15, the average is 7.5. The average multiplies by 2. So the mean is multiplied by that amount. I'm not putting 2 because just multiply by the same amount, whatever that amount is. And what happens to the standard deviation? Does it stay the same? No. It's multiplied by that same amount, right? So standard deviation is multiplied by that amount. Okay. Okay, let's see what you think you know. So What is the standard deviation of a class if everyone in the class scored an 85% on the exam?
It'd be deviation from what? Like, because they don't
Yep.
change the average. They're all the same.
They're all, the spread is, they're all the same. So if every single person in the class got an 85%, I would agree it's 0.
Yeah, that makes sense.
What, mathematically, does that make sense?
Yeah.
Why?
Because there's no shift or change.
Yeah, there's no shift. There's no variation. There's no,
There's nowhere for it to go. There's only one option.
true, that's it. It's 0. You're right. What would the average be if everyone scored an 85?
85.
85. And then if we figure out standard deviation, what do we do with that average?
Subtracted.
Subtract it from each person's score. What's 85 minus 85? 0. Squared is 0. So you average all those zeros, you get 0. Square root that 0, you get 0. So the spread is nothing. That's why standard deviation is 0. It's very small. In fact, it's 0. So I agree, it's 0. And why? I guess we could say there's no variation. They're all the same. There's nothing to solve. In fact, I'll just go 85 is the average minus 85 is 0. Right? You square that, still 0. And so mathematically, you can say something like that. Okay? Okay, open your packets. I want to have you look at what the homework entails here. So let me get a front packet. Okay, so this assignment hopefully should not be difficult, just number crunching it here a bit. Okay, so it's kind of nice. They set up a chart for you here. So you have 2 students, Elvira and Bob. Okay, we're in the same psychology class at Clearwater State University. There were 10 quizzes taken during the semester. The students' scores were as follows. Okay, Elvira's 85%, 87%, 90%, 84%, 87, 85. Good old Bob. Bob failed his first quiz, 53%. But then comeback kid got a 97, 75, 80, 90, 45, 71. Aced it. So Bob is kind of a little inconsistent there. But so which student do you think had the lower standard deviation? Who had the smaller standard deviation number? There you go. The spread of numbers are real close to each other. Okay. Justify your answer. Actually, just wait, and you're actually going to figure it out. They started. This is Elvira's. Okay. Elvira's exam score is 86, so they put it there for you. They listed all that out. So you'll just number crunch. You'll find the, actually there they put variance. You'll find that, then you'll take square root, you'll get Elvira's standard deviation, and then you'll figure out Bob's standard deviation, and that'll answer that. So, so that's pretty much what your assignment is. If you look at the others, that's all they're doing. Let me start you actually on, turn your paper to this page, I guess. It says calculate the mean, variance, and standard deviation. So what numbers are in the set here? They gave us a little table like this. What does this mean? There you go. So you would put a 4 there. There's another 4. There's a 5. There's a 6. There's a 7, a 7, and a 7, and a. Okay, does that make sense? Okay. And then you got to find the average of those, and then do all the rest. Right. Okay. So, and don't forget on the back, there's some standard deviation problems on the back there. Okay, so very doable assignment. Just got to crunch a lot of numbers. No excuses for not having this done, right?
Yes, I can find many.
Even if you are playing a video game.